classes. Today we continue our talk and we will focus on the G code and M code. So here is this is the tools machines. Okay, most are made from the high steel, tungsten carbide, or ceramic tools. Tools here, and some tools need a coolant such as oil to protect the tool and the work. And we will have this is the project, and this is the Friday I'm going to give you. We will have a couple of projects. So we will one project, and we will cover how to use the coolant, how to use the coolant to facilitate, to help machining. The tool pass and cutting and parting these motions. The tool pass means that and how you want the tool to move. So this is automation. This is about automation. Whenever you write a program, and before you put the workpiece there, and before you machine it, and you just do it without the workpiece. You want to see if the tool is moving correctly or not. So this is a tool path. We talk about tool path. Tool path is and how the tool, the trajectory, how the tool is moving. The tool path describes the route of the cutting tool, the cutting tool takes. Motion can be described as point to point, is point to point. Next, the straight cutting or contouring. And point to point moving is without machining, but this is just from one point to another point. The speeds are the rate at which the tool operates. And for example, this is the RPM, the rotational speed. The feeds are the rate at which the cutting tool and workpiece move in relation to each other. Is the feed. Is the field. Where we know the feed. And feeds and speeds are determined by cutting parts, the trajectory, the material and quality of finish needed, and also, for example, these are harder materials need to lower the feeds and the speeds. So, and we know. So just suppose, and you are very good at the operating the machines, operating the lathe machine, milling machine, and all other machines. Now you just want to automate all these things. Okay, so the routing cars remove large amounts of materials than finishing cars. Roughing cars is ROUTH. Roughing cars remove larger amounts of materials than finishing cars. Rapid traversing allows the tool or workpiece to move rapidly when no machining is taking place. Rapid is transfer, as from one point to another point, and without machining. And without machining, and you can just move the tool very quickly. So tool movement and interpolation. Have you guys ever heard of this interpolation? Interpolation means that from 2 points, if we have this is the 2 points in the middle, in between, and how we are going to move, the tool is going to move. Interpolation is called interpolation. So here, tool movement. So this you have here. Okay, this is the first one, linear movement, and from one this is one piece from one location to another. So this is a linear movement. And B, this is a continuous path approximated by incremental straight lines. So here, move from here and go here and go here. So here is this is the tool path and how the tool is moving. And here is also the tool path. Right? That is what's called tool path or cutter path. So here is a cutter radius. So here is the center of the cutter. C is circular. So C is circular. They can move. This is circular. Right? So this is a straight line corresponding to the other one. So here is continuous path. This continuous path. Here is this the circular. There's a quadrant. This one or this one. This is a full circle. And so this is a segment. And how to rotate? These three are the basic the movement of the tool when you use the CNC machine. So here, actually, we talked about this slide already. So here is the tool path. And so here is a schematic illustration of drilling. It's a drill the piece there, drilling and boring. And boring and milling operation with various colored parts. The first one, various colored parts of the tool parts. So B is so here is drilling and boring. And here is this one is point to point and the straight line is a straight line milling. So here is a 2-axis contorium, okay? Contorium with the switchable the planes. This one is a 3-axis contorium, continuous is the path. So this one is a machining a sculptured surface on a 5-axis numerical control machine. So this picture we showed. I want to show you again. So how to program? Here are the basics for the CNC programming. CNC instructions are called part program commands. This is a command. For the mechanical engineering students, so in the senior year, and there will be another class called mechatronics. In mechatronics, we are going to learn the industrial robots. Industrial robots is very similar as this one. Okay, so this is arm to move around. So that's also command. Here is the commands also. So when running a part program is interpreted and interpret one command line at one time until all lines are completed. So this is the program. This is a program, and the machine know and how to interpret this program. The commands, which are also referred to as blocks, we call blocks, okay, are made up of words which each begin with a letter, address, and end with is a numerical value. I'm going to show you this is an example and how to write this is the CNC program. So each letter address relates to a specific machine function. Each letter, every different letter has different the meaning. So G code, mainly G code and M code, G and M, right down here. And G and M addresses are two of the most common is letters. The G letter specifies the certain is the machine preparations, such as inch or metric modes or absolute versus incremental modes. So G1. M letter specifies miscellaneous machine functions and would like on and off switch for coolant flow and tool changing or spindle rotation. Other letter addresses are used to direct a wide variety of other machine commands. Mainly G and M, G code and M code. So we should know that. Here, programming important things to know for the CNC programming. Because there is a position, there are a lot of positions here, right? From one position to another. So that's the reason we should know the coordinate system of your machine. So this is very similar for the industrial robots. By the way, industrial robots or industrial arm is also called another is automation. The units, you need to pay attention to units, and also whether this is incremental positioning or absolute positioning. The coordinates we have the 6 degrees of freedom, X, Y, Z, and also Rx, Ry, and Rz. Right? So 6 degrees of freedom. Each generic point will have 6 degrees of freedom. X, Y, Z is the 3 translational degrees of freedom. Rx, Ry, Rz are 3 rotational degrees of freedom. Feeder rate and spindle speed. You know that feeder rate and spindle speed. And coolant control is on or off, or is a flood coolant, or this is mist coolant. Mist is a minimum quantity of the cooling. But for this flood, it's fully immersed. The tool control and tool parameter. So what kind of tool? what kind of tool you are using, the turning tool, milling tool, or filling tool, and then associated with the tool parameter. What kind of parameters you are using. So this is the CNC programming. The second one, so programming consists of a series of instructions in form of letter code. In form of letter code. Here are these are preparatory codes. Preparatory codes. For the T code, okay, as I said, T code and M code. T code initiating initial machining setup and establishing operational condition. T code. Also have N code. So N codes and specified program line number to be executed by the MCU. MCU is a computer. N code is a line number. And then the axis code, XYZ, and used to specify motion of the slide along XYZ directions. Also feed and speed code, F, D is very, very intuitive. F stands for feed, S stands for the speed. Specify feed and spindle speed. And two codes, C the T, two codes. The M code is miscellaneous code for coolant control and other activities. What I want you guys to know is T code and M code, and they are very, very important. Right? T code and M code. The T code is the initial machining setup and establishing operating conditions. And M code is for the miscellaneous code for coolant control and other activities. So by the way, for all these CNC commands, CNC programmers, CNC commands, we call T code and M code. What? T code and M code. These are programming key letters. So first, O means the program number and used for program identifications if we have multiple program. N is a sequential number. N001 is first statement. N002 is second statement, and so on and so forth. And T is a preparatory function. T, x-axis designation, y-axis designation, z, and z-axis designation. So this x, y, z, R is the radius. Okay, the radius of the tool or some is a radius designation. F is the feed rate. S is spindle. H is the tool length offset designation. The tool length offset designation. Why we have this one? Because the tool is always have radius, right? When we specify tool parts, actually we are specifying the tool's center, the tools, center of the tool. But we need to take care of the offset value. D is a tool radius offset designation. And this T is a tool designation. M is a miscellaneous function. Y is a H is tool length, D is a tool radius. Here, the commonly used T codes, and here are the explanations of the commonly used T codes. First one is T00, a preparatory code to control final position of the tool and not concerned with the parts that is followed in arriving at the final destination, T00. And T01, the tool is required to move in straight line. Okay, T01 is required the tool to move in straight line, connecting the current position and the final position. This current position and final position. Final position, you specify the final position. Okay? So used for tool movement without any machining and point-to-point control, linear interpolation. And I would suggest you just draw down. T01 is for the point-to-point control. Write down. T01. T02, two paths followed is along an arc. T01 is a straight line. T02 is an arc. It goes follow arc. The specified by IJK code. And so T01 is a straight line and T02 is an arc interpolation. Write down. T01 is linear interpolation, and T02 is the circular interpolation movement. Right? So even though the final exam will be typical, but still I want you guys to know this is the fundamentals. So if you have an interview and they will ask you, have you guys ever heard of T code or M code? Yes, I heard it. I learned in manufacturing processes. And what are T code and M code? What is the T01? So use your own language, tell me T01 is what? T02 is what? T01 is the linear interpolation of the tool. T02 is the circular interpolation. Okay? So this is a movement, the tool movement. And here is a table of important T code. T00 is rapid transfers. Rapid transfers from the current position and to the position you just specified. Right? So T01, linear interpolation of linear with some speed. And T02, circular interpolation is a clockwise. And T02 is a clockwise. And T03 is counterclockwise. Write down, okay? So you still need to memorize some facts. And T17 is work on the XY plane. And T018 XZ plane, T19 YZ plane. The T20 or T70 use the inch unit. I'm using the English unit. And if I specify T20 or T71. T21, T71 is a metric unit. Or Carter combination cancelled, Carter combination. Okay, the radius combination, the cancel, Carter combination left, Carter combination right. On which side you want to do the compensation? Offset, or compensation offset. So T33, two length compensation, and two length compensation for the this is T43. I'm sorry. This is plus. Two length compensation. This is minus. I just two twice. I'm sorry. Just one. Okay. T49. Two length compensation cancelled. You can specify compensation, and you can use T49 to cancel the compensation. One command enable, another command disable this function. And T80 cancel the penned cycles, and T81 drilling cycle, 82 the color boring cycle is going to do boring. The deep hole drilling cycle, absolute position T90, and you are using absolute positioning, and T91, and you are using incremental positioning. There are so many commands, right? This is the convention. This is the convention. If you want to build your own CNC, if we want you sell your CNC in US or in the Europe or Asia, and you must follow this one. Understand? So this is a convention. So this is the you know what convention is? Convention means that people in this community have recognized this is a code. Okay? We call this a code. Everybody recognize this is our rules that we need to follow. Otherwise, you need to specify. You just customize something and you need to explain. Whenever you see the T17, it means XY plane. And you cannot specify another one. If you specify another one, you need to explain. Or your product cannot be sold in the US. Why? Because people are not familiar with your designation. Understand, right? Okay, so here, so this is the basic the T code. M code. So this M code, M means miscellaneous, and there is a lot of miscellaneous things. For M00 means program stop. And if you specify M00, use this M00, the program stop. M01, optional, the program stop. Optional, okay? And this is M02 program end. Is a program end. Program stop and program end is different. Program end means that this is my program from very beginning to the very end. But program stop is something happens, I just stop it. If some conditions are met, I just stop it. Make sense? End means the natural end, natural finish. But this stop means something if some conditions are met, and I want my program to be stop. So this is spindle on clockwise. This is M03, spindle on clockwise. M04, spindle on counterclockwise. 05, M05, a spindle stop. I can just stop the spindle. The tool change, M06. If I send this list command out, the tool, I'm saying the stop, rotating the tool will be changed. The coolant is on, M08. If you see M08, the coolant will be turned on. M09, coolant off. M10, clamps on for the workpiece. M11, clamps off. M30, program stop. You set to stop. Can you memorize all these codes? I cannot, okay? But the bottom line is that you know if there is a need, after take a look at this one, you can program your own, and if you boss ask you, hey, and please interpret this is the program written by other guys. And you know how to use this table to see, right? And what each of these statements stand for. The program command parameters. So optimal machining programming requires consideration of certain machine. And you just consider the CNC is the computer control system, including the positioning control, compensations, and also special machine features. Positioning control is the ability to program tool and machines slide movement simultaneously along two or more axes. This is positioning control. The positioning may be for the point-to-point movement or for contouring movement. It's a contouring movement, continuous movement along a continuous path. The contouring requires two movements along multiple axes, okay? Simultaneously, not just in X direction or in Y direction or Z direction. It might be follows three directions simultaneously. This movement is referred to interpolation. If you have never heard of this is a word, interpolation means that I have two positions. Interpolation means that I find the place, find the other locations that's located in between, right? As the name suggests, interpolation. So this guy has, there's another opposite meaning is what? Extrapolation, right? Extrapolation. Have you ever heard of extrapolation? No? Extrapolation means this is my data. This is my range of data I know. Here, out of my range, okay? I want based on this one, I want to extrapolate. It's called extrapolate. Extrapolate means X means EXTRA, extrapolation. Extrapolation means that outside. Interpolation means inside. Interpolation means that I have different points. Some points here, some points are unknown, some points, some position, but to the interpolation means that I find other locations in between. So this is called interpolation. Another one is called extrapolation, which is the process of calculating intermediate values between specific points along a programmed path and outputting and those values as a precise motion. So interpolation may be linear, having just a start and end point along a straight line, or circular, mixed circular, which requires an end point, a center, and the direction around the arc. So this is called interpolation. Interpolation and extrapolation. So the rules for programming. So here is a block. We call it block, or we call it command, or we call it instruction. The same thing. This is the block, the format. So here n is number is a line number. Okay, so the theory you have to have a line number. The line number is increasing from the top to the bottom. It's a line number. So this is a function. This is a function T01. X, Y, Z. So this is the position, and this one, this F5 is a feed rate. Okay, see, sample block distribution on CNC blocks. Each may contain only one tool move for T01. What is T01 does? What does the T01 do? Linear interpolation, linear movement, right? So yes, linear movement from the current position and to this position with this speed. Right? So this is how we interpolate this one. And each may contain any number of non-tool movement decode, and each may contain only one feed rate, is a feed rate, and each may contain only one specified tool or spindle speed. The block numbers and should be sequential. Should be sequential from the lowest one and be increasing until the highest one. You cannot change. If we change, and the system will follow the instructions based on the number. Okay. Sometimes you want to try. I have never tried that. That might be the problem. I think very cause people problem. So the both program starts flag and the program number must be independent of all other commands on separate lines. The data within a block should follow the sequence and show in the above sample block. I'm going to give you here is one statement. I'm going to give you a program to see. Let's see is the program. This is a CNC program later. And then we talk about CAD and CAM. And you guys know CAD, right? Computer aided design, right? Right? Computer aided design kind of model. What is the CAM? And CAM is computer aided manufacturing. Have you guys ever heard of CAM? And CAD, you design the model, and CAM, what does the CAM do? CAM is change this, what is the model you have to G code and M code. Right? So the two computer-based system, which instead use of CNC technology, are computer-aided design. This model, it's computer-aided design is for the model, the final product. Computer-aided manufacturing. The CAD system uses computers to practically create product design models. Right? Abacus is a model, but Abacus is a CAD model, but also they have very powerful and financial element for the capacity, right? So here I'm only talking about the pre-processing within Abacus. That means CAD. SolidWorks, Creo, all these guys are CAD. CAD. Now this design can be reviewed, revised, and refined for optimum end use and application. Once finalized, the CAD design is then exported to a computer-aided manufacturing and CAM system. What is CAM? I want you guys to remember, okay? CAM system assists in all phases of manufacturing a product, including process planning, product planning, the machining, scheduling, management, and quality control. This is CAM system. Any questions? And here is another acronym. It's called CAPP and CAPP, a computer-aided process planning. Process planning, right? Process planning. And CAPP, usually people write and CAD and CAPP and CAM. Whenever you see this one, don't panic. CAPP means computer-aided process planning. Right? Right? But at the very beginning, this is the very beginning of the development of CAM. But now, people include the CAPP as part of this CAM. When I was young, when I was at your age, we have 3 different branches: CAD and CAPP. If I know my CAD final product model, and based on what kind of machines I'm going to use, I generate a CAPP, right? Generate CAPP process planning. which statement do milling first, do drilling first. Second, want to do this is turning later. And CAD means generate the two parts, T code and code. But now the CAM, the people include the CAPV into this CAM. CAM is broadened. And here is one example, guys. So this is my raw material. This is a very simple problem. So this is my raw material. It's 70 millimeter long. This is 25. This is diameter is 25. And my final product is this. And my final product is the step. This is the step. There's several steps. So this is my original one. So this is my final one. So the smallest one is 1075. The length of my this bar part is 20. And the intermediate, this diameter is 22.5. And from this red end to here is 30. So for this part, for the remaining part, I do not do anything. Now, I want you guys to write the T code and M code and to automate this is the processing. Turning, using turning. And we will not argue feminist. You know what I'm going to do, right? So this is a bar, run a bar. This is my raw material. So this is my final product. I want to write the T code, M code. Question.
You make right cards.
Huh?
You make those right cards.
Yeah, we can make this CNC order. Yeah, so this is the very simple example. The CNC machine center, we can do much more, 10 times or 100 times complicated the system. But you need to know the T code and M code. Okay. So this is what we want to do. We want to generate this kind of final product based on this is our raw material. So here is a mode. No, I'm sorry. Here is a program. So this part, I want to generate my first step. Right? Generate first step. So O0013. What is does O? O means the program number. So N005, T53, and what's the TF53? You need to come back to this one. Where T53 is wait, we have T53, we have T00303 and T57. I'm going to show you one by one. Okay, so here, so G00013 is a program identification number. So this is a program identification number. And T53, yeah? So to cancel any previous working 0 point. So this is the T53. And T53 is to cancel any previous working 0 point. Then we have sequential number N0010. So T03, right? So T03 select the 2 number and 303. The T0010 is a sequential number, is a line number, and T0303 means that you are going to select the 2 number 303. And then T57 sets the working 0 point as same. T77 00 is a rapid movement, and T00 is a rapid movement, no cutting. T01 is the linear interpolation, linear cutting. Okay, so T57 CT T57 sets the working 0 point as same, and T00 rapid movement from the current position and to this location. And S500, S is a spindle speed, right? Spindle speed is specified as 500 RPM. M04, and rotate the spindle counterclockwise. So this is this statement. And so this is the interpretation of this statement. So G00, rapid movement, no cutting. XZ is a two is a position, okay? And because I don't move in Y position, in Y, I only in the X direction and the Y Z direction. X direction and Z direction, 6.0 and Z00, and the spindle speed is specified as 500 RPM. M04 specifies to specify the rotation of the spindle speed counterclockwise. So this is what this statement states. Next one, T01. T01 is a linear interpolation, right? Linear interpolation carding, and this position in X, right? In X, this is X direction from my current position to my final position, and F is a feed, and the feed rate is 100 and 100 millimeter per minute. So this is the feed rate. And then O0000 T00 is a rapid movement, no cutting. I move rapidly away from one piece, right? And then Z direction is a horizontal direction to Z or 240. The movement is 2 millimeters away from the face. From here, I move in the Z direction by 2 millimeters. Z direction is in the horizontal direction. And then this X50, Z50. If I do not have any other T code, okay, that means this T00 is still valid. You understand, everyone? You understand? So look at this statement. This statement, I do not have any T code. That means this T00 from the previous statement is still valid, which means that this is a linear movement without cutting. Right? Questions? So go to a safe location away from the workplace. X is 50. X is a vertical direction, and Z is a 50. So X 50, Z 50. Z is 50. To change the tool, I want to change the tool now. And then I change to tool 404. So then T57 is T00, rapid movement, no cutting, to X and Z with this spindle speed. So G57 to set the working 0 point as saved G57, right? So here is I have another T57 as saved, and so here is T00 go to T0 using T00 go to X and Z with this is a spindle speed, which equals 500 RPM. Next one is T01. T01 is linear movement cutting onto this place. If I don't have X position, that means X position, X coordinate remains the same. You understand? If I do not have new X coordinates, that means my X coordinate does not change from my previous statement. I only change it in the Z. This is my Z 2.0, and now this is my Z is minus 30. And this is a whole line, okay? From horizontal line, from here to come to 30. Yes, horizontal. And the feeder rate is 100. This is the turning 100 millimeters per minute.
Is that telling it how fast to move?
Yes, from here, yeah. From here to here. Turning. the turning tool. We have the
Yeah.
turning tool.
Because it's been over.
Yeah, yes. And so at the very for this statement, we are here. We are here at the very beginning of this statement. And then we go away from here. Right? And go all the way down from here. We have our first step. And then T00, after you cut it, you need to come back, move rapidly away from workpiece without cutting. And to location 23.0 and Z equals 2.0. And with the special feeder, this spindle speed is 500. And the next one is G84 turning cycle for machining the step. And so I finish this one. X, so you can see, okay? For here, I have G84, but I do not have G00, G01, and G02. It means that this is G00 is still valid, right? Z, go to ZG collision. Length of the step is 20, and D0 equals 200, and finish allowance in the X direction, finish allowance equals 0.2 millimeter. And D2 finish allowance in Z direction is a 0.2, is a finish allowance. And you just specify the finish allowance D0 and D2. And this D3, the depth of cut in each part, the depth of cut. You know depth of cut, right? For turning is for turning. This guy is spinning. This is my tool. This direction is the depth of cut. This direction is the feed. So remember, so this is a tool. If I move this way, the feed. If I move this way, depth of cut. So you know D0, D2, D3, D3 is the depth of cut in each pass. T00, after that, T00 move rapidly away from workpiece. T00 is move rapidly away and to Z 2.0, X does not change. X value does not change. So it's still using T00, move to the tool changing location. It's a tool changing location. So we're still using T00. M30.